Hello everybody, in this lesson we're going to look at the population versus sample and one sampling method. So the learning objectives are understand the distinction between a sample and the population, appreciate the randomness of choosing samples, and explain in simple terms why a given sampling method might not be unsatisfactory. We are going to use random numbers to produce random samples. Here we have three methods for random sampling. First is simple random sampling. When we pick randomly from a bag, we just put our hand in the bag and we pick some marbles, or we close our eyes and we pick some people from a group. Simple random sampling. Systematic random sampling. For example, if I want a sample of size n, 20 let's say, I'm looking at what is the smallest, what is the highest of the values in my population. I divide the interval into 20, the sample size, and I pick randomly from each interval one element. Systematic random sampling. If I want all elements in my population to be represented. Stratified random sampling is similar when I create some strata. So imagine population on the globe. 0 to 10 years old will be one strata, 10 to 12 be another, 20 to 30 another, 30 to 40 another. And I pick samples from each strata, one sample, to then put them together and draw some conclusion about the population. In this way, I'm sure that each strata, each segment of the population is represented in my conclusions. On the next page, we are going to use a random number generator to do simple random sampling. We can't put our hand in a bag to pick something, so we're going to use a random number generator to generate some numbers that will help me choosing samples. Imagine all people in the world, and this form our population, the population of all people in the world. We are interested to find the mean height of all people. That will be our parameter, the population mean for the height. Of course, because people have different characteristics. So we're going to look at the height. Population mean is called the parameter, and it's the height of the mean height of all population. Now we can't measure all people in the world. That's why we are going to take a sample. One part of the population that we choose and is manageable. The size of the sample can be 4, 10, 20. So the sample size is very important. It's important as well what sampling method we use, how we choose sample. For example, if I choose sample from all people in a school, then I only have people between 2 and 18 years old. So it's not a good sample. It's not random. I'm biased in my choice. So assuming my population is correctly chosen, is an unbiased sample, and I'm looking at the sample mean. So instead of looking at the population mean, which I can't find, I choose a sample and I'm looking at the sample mean. This sample mean, I record it. I choose another sample and I'm looking at another sample mean, and so on. From all these sample means, I will draw one number which is called a statistic. I use this one to estimate the statistic. I use it to estimate the mean of the population, the parameter. So I'm analyzing the samples, interpreting data, collect data from many samples, analyze again, interpret. And from all these means of all samples, I draw conclusions about the population parameter. Of course, the number that I get for the population parameter is not going to be exact, it's an estimate. But I need all my methods here to be accurate, scientifically based, so that they give me an accurate estimate of the population parameter. This part of statistic is called inferential statistics. Now I invite you to pause the movie, read this question, and try to identify in the description the population, the parameter, the sample size, and the statistic. If you decided that the 500,000 international students is your population, and the parameter that you use is the average yearly expenditure of the students. So that's a population parameter. And then the study interviews 500 students, so that's a sample. The sample of size 500, the 500 students. So we identify population parameter, sample size is 500, and the statistic is the mean that you get from these 500 students. We ask each of them how much they spend yearly. The mean of those numbers will be the statistic, will be the number that I use to estimate the mean or average yearly expenditure of all these international students. Let us know how do we find a random sample. And random means unbiased. So all elements in the population have equal chances to be picked. So I choose, for example, this population. It's a small one, but this is for exemplifying. So I have 12 elements in my population. To find the random sample, I will use a random number generator. So this command on your calculator will return you a random number between 0 and 1. So you can be sure that the computers have embedded in them algorithms to give you random numbers. Now, what I need from this number is to generate numbers, whole numbers between 1 and 12. So as my interval has a size 1, if I multiply my number, let me call r the number that I get. If I multiply r by 12, because I have 12 numbers, then the interval will be between 0 and 12. So any number between 0 and 1, if I multiply by 12, I'll get some decimal number between 0 and 12. Now, because my numbers are number from 1 to 12, number 1 actually is not picked, right? So this command run of hashtag will give me a number between 0 and 1 with 0 included and 1 not included. Now, I want to generate whole numbers between 1 and 12 because that's how my numbers are numbered there. So I will take the whole part of this number, so ignore the decimals, and I will add 1 because then the interval 0, 12, if I add 1, will turn into 1, 13, with 1 included and 13 not included. And the number that I get will be corresponding to the numbers that I pick. So let's try. By using this command, I get on my calculator, if I type, and I get 3.252. So I just round to 3. Yeah, so round to 3. And then I add 1, and I get 4. So I pick the 4 element. The 4 element is element D. And I read whatever characteristics I want from this line. Let's do it again. If I press again, run on my calculator, I get 0.408. I multiply by 12, and I get 4.896. I just round it by ignoring the decimals, so I get 4. I add 1, I get 5, and the number that I picked is E, with all the characters. So that's the second number of my sample. If by continuing the procedure, I end up, for example, again with D, then I ignore the line and I try again until I generate the sample of the size that I want. The format that you used here in order to generate the sample was rand hashtag times 12, because we have 12 elements in the sample, in the population, plus 1, because we wanted to generate numbers from 1 to 13, excluded, not from 0 to 12. And then what we did was that we use the word truncated the result, in the sense that you just ignore the decimals. truncate the result, so you ignore the decimals. That's what I did here.